हेलो एवरीवन। आप सभी का स्वागत है इलेक्ट्रॉन फ्लो एकेडमी में। तो और today's topic is RMS value, which is very important concept in AC circuits. Okay, so the definition of the RMS value is like the RMS or effective value of an alternating current is equal to the direct current, which when flowing to a given resistive circuit for a given time of interval. So that current flowing which is flowing in the resistance which produces the same heat as produced by the alternating current when flowing through the same circuit for the same duration of the time period. Okay. So basically the power transfer capability of an AC voltage or current depend upon the RMS value. Okay. So the significance of the RMS value is the power transfer capability. Capability. Okay. So which is depends on the RMS value of the current and the voltage. So basically the RMS value are of considerable importance. In fact, in all the calculation, RMS values are used unless otherwise specified. Okay. So basically the RMS value of an AC quantity is denoted by the capital letter of the V and I like this. Okay. And the methods for determining the RMS value basically are of two types. So firstly we are going to discuss about the method one, which is known as the mid-ordinate method. Okay. So in this method, let us consider the current waveform, like which is showing in this figure. So in this current waveform, as we can see that the current is divide its base into n number of equal intervals, each of the duration of t upon n seconds. Okay. So here what we have done, we have divided the waveform in the n number of the interval. Okay. So basically what's happening here, we are assuming that the current is flowing in the resistance, which value of capital R, and this is the value of the current, which is the small I. And secondly, we are considering the same resistance in which the capital I current is flowing. Okay. So here let I1, I2 and In like this. This is I1, I2 up to In be the mid-ordinate magnitude of the wave in the successive time interval. Okay. So suppose this current wave is passes through a resistance R for the T duration. Okay. What we are assuming that this current is passes through the resistance R for T duration. Okay, this is our we are assuming here. So therefore, the heat produced by the current wave in nth interval. Okay, so what is happening here? 1 minute. Yes. So what is happening here? Yes. Therefore, heat produced, which is denoted by capital H N by the by the current wave in nth interval, which is given by is given by following equation. Just a minute. It is given by following equation, which is equal to h of n is equal to 1 upon j multiplied by I square r t divided by n calories. Okay, so this is what is this? This is the total heat produced by the current wave in t seconds. Okay, so this is given by h of n is equal to 1 upon j multiplied by this expression I square or I1 square r multiplied by t divided by n plus I2 square r multiplied by t divided by n like that up to I square in square r multiplied by t divided by n. So this is the total heat produced by the current wave in t seconds. So we can rewrite this equation like h of n is equal to, we have take r common. So the equation now look like I1 square plus I2 square plus I3 square plus up to In square divided by n. Okay, so this is our equation number one. Okay, so next, now we have to assume that, or let capital I, okay, this is capital I, be the DC current which produce the same heat in the resistance R. Okay, same resistance R during the same time of interval. Okay, same time of the interval. So therefore, for this condition, the total heat produced by the DC current is given by H is equal to I square multiplied by R into T divided by J. Okay, so basically J is here the Joule's constant. What is J here? J is the Joule's constant. Okay, so this is our equation number two. So by equating the equation number one and two, okay, so one is equals to two. By equating the both equation, we can see that here I of square R into T divided by J is equal to R of T divided by J multiplied by this expression I1 square plus I2 square plus like that up to In square divided by n. So by equating the both equations, we know that here the value of the I square is now equal to the this expression I1 square plus I2 square plus like this up to In square divided by n intervals. Okay. So from this equation, we can see that I is equal to under root of the expression I1 square plus I2 square plus like that In square divided by n. Okay. So from this expression, we can say that the value of the I is nothing but the under root of mean, or we can say that is the average, okay, of the square of all of all the instantaneous value of current. Okay, so this is how we know that with the help of the mid-ordinate method that the total value of the I is nothing but the square mean of all average instantaneous values of the current. Okay, so by the definition, capital I is the RMS or the effective value. Thus, RMS value of the alternating quantity is numerically equal to the square root of the mean of square of all instantaneous values. Hence, the name RMS. RMS meaning is here root mean square. Okay, root mean square. So because of this, the name formation is done like this. Okay, so this is the first method which is known as the mid-ordinate method. Okay, second method which is known as the analytical method. So analytical method is used when we know the equation. Okay, so in order to determine the RMS value, we have to find the squares of instantaneous values. Then mean is taken and finally root is taken. So let us consider this sine wave. This is the sine wave. Okay. So the equation of this sine wave is equal to I equal to Im sine of theta. Okay. So we can rewrite this like I of square is equal to Im square sine square theta. Okay. So the waveform of the I, this is the I and I square is shown in this waveform. Okay. So this is the I square waveform. Okay. And this is the waveform of the I. So next, what we have to consider here. So let us consider an elementary strip which is showing here d theta. Okay. So here we are assuming the elementary strip. So of the thickness of this strip is around d theta. Okay, so on the I square waveform, so let the ordinate or we can say that the instantaneous magnitude of this strip be I square. So the therefore the area of that strip is given by area of the strip is given by dA equal to I square d theta. Okay. So we are assuming this elementary strip on that I square wave. Okay. So now the area of half cycle is given by A is equal to integration 0 to pi I square d theta. Okay. So this is equal to the sum of squares of instantaneous values. Okay, so this is the value. So as we know that here mean over half cycle is given by that value integration of 0 to pi I square d theta divided by area, divided by periodicity, which is the pi of the half cycle. Okay, so further we have to solve this equation. Okay, so or we can take here RMS value like the root of the mean can be expressed here capital I is equal to under root of 0 to pi I square d theta divided by pi. Okay, so now we have to solve this expression. So what we are doing here, we are substituting the value of I square. So here we are substituting the value of I square. Then we get the value of I is equal to under root of 0 to pi. The value of the I is Im square sin square theta. So put that value. This is pi 0. Im square sin square theta d theta divided by pi. Okay, so let's solve this further. So Im multiplied by under root of 1 upon 2 pi. The integration of sin square theta is equal to 1 minus cos theta cos 2 theta multiplied by d theta. Okay, so this is equal to Im square under root of 1 upon 2 pi theta minus sin 2 theta divided by 2, and the limit is of 0 to pi. Okay, so if I solve this equation further, the value of I is equal to now Im multiplied by 1 upon under root of 1 upon 2 pi into pi minus 0. Okay, pi minus 0. So the value of I is equal to now Im divided by root 2. Okay, so this is the value of RMS value of the current, which is equal to the Im divided by root 2. Okay, so this analytical method, we have done for the sine wave. Okay, so we can say that here for a sine wave, RMS value is equal to 1 upon root 2 of maximum value. Okay, so this is very important expression for the sine wave. Okay, so it is to be noted that the DC quantity average value, RMS value, we can calculate with the help of the two methods, which we have discussed in the earlier lecture. The two methods are as here discussed. First one is the mid ordinate, okay, and second one is the analytical method. Okay, so thank you very much. Kindly like and subscribe our channel.